The main mathy thing that you're going to be taking away from this lesson right now is how to draw a line of best fit by eye. And some of it is like kind of winging it, but there is a definite way that you need to calculate this before you draw your line of best fit. But first, we need to draw a scatter diagram. Our x-axis is going to be hours. It does tell us that it is x. Your textbook talks about something called explanatory versus response variable. It's just yet another way to talk about dependent versus independent. So your explanatory is something that's like explaining the situation that's going on, and then your response is what has responded to the x-axis, the thing that you've then were discussing. So it's like your independent, where it's just something that you've chosen to look at, and then you're dependent of like, does it depend on your independent? So it's just a different way to reference it. Your check for understanding does ask about this. So just make sure to write down that really what it is explanatory is your X and response is your Y. We should talk about this just in reference to what do we put where. And it's like the response should be the outcome of the test, right? If I wanted to know about how many hours of studying versus their grade, you can go in before you've looked at the grade, you can pick out the hours, and then the grade is what happens afterwards. So kind of this like result of your study, or this response to what has happened previously, it's kind of like the second thing that happened typically. Tough sometimes, but we can continue talking about it for the rest of this unit and the rest of this year. Your x-axis should be hours. Yes, you need to label it. Yes, you would be marked down on the IB exam if you do not label your axes. On your test, some of you did not label your axes, and I still gave you points, but just realize that the IB would mark you down if you didn't label your axes. Okay, we have 1, 2, 3, 4, 5, 6, 7, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. $70, $80, $90, $100. And then go ahead and plug in your points. Finishing up your scatter diagram, it should look something like this. It's a pretty strong, positive, linear association, which makes sense that the more hours you study, you should probably be getting a better grade on your test. So it says to finish drawing the scatter diagram and then draw the line of best fit by eye. Doing the line of best fit by eye, I've run out of lead. First, you need to find the average X and Y values from your table, which means you need to find the mean of your X values and the mean of your Y values. Your textbook gives you this formula where it's like x bar equals 1 over n times the sum of all of your x terms, x sub I, right? And all that means, since we had 10 pieces of information, is you multiply by 1 over 10, which is the same as dividing by 10, and then you add up all of your x values. Adding all of those up, right? This sum is just add all the terms that you got. Adding them all up, it's 51.5, which means then dividing it by 10 is 5.15 as our average of our x values. We're going to go ahead and do the same for our y values. Adding all of those up, we get 774. Dividing it by 10 is 77.4. So that is your average point. And so your second point, or your second step, is to plot this idea of this average point. So 5.15, so just slightly more than 5. And then 77 would be kind of like right here. Yeah. Then your third thing that you do is really just draw what you think is the line of best fit. When I go through with my ruler and then try and draw in what I think is the line of best fit, I try to balance like how many points are below it and how many points are above it, right? So like this might look like it fits a lot of these points, but realize I've got a lot more points that are under it than I do above it. So I'm going to try and balance that out by like maybe adding 1 or 2 more points to be above it, right? Trying to balance out. Here I've got 4 points that are above it, and here I've got 4 points that are below it. And so that's kind of how I do it. We will talk about how good is your line of best fit, and it's called the least square regression calculation, and it's pretty much calculating the distance away each of these points are from your line of best fit. So if you're doing it by eye, I try and balance out how many points do I have above and how many points do I have below, and then I try and draw it. And while it looks like it really just didn't have as many points lining up with it, right? Like maybe you wanted to do it this way because you had a bunch of points lining up with it. It balances out how much is above and how much is below. And it's also all by eye, and so yours might be slightly different than mine, and that's okay. All right. So our next question says, use your line of best fit to predict the score of a student who studies for 4 hours. So since your line might be different than my line, you might get a different answer. So I'm going to show you how I did it for mine, and then I'm going to ask you what you had on yours. So you maybe have copied what I have done here, but if you have not, go ahead and try and calculate what do you think the student got for 4 hours. So here, if I look at 4 and go up to my line of best fit, do not use the point that is already at 4. That is not the point of using a line of best fit. Do not use a data point. This is one example of a student who studied for 4 hours, but he does not represent all of the students who studied for 4 hours. The line of best fit is the line that you use to then predict all of the students who studied for 4 hours. So while you go to 4, you ignore this data point that already has 4, and you have to use this line right here. And I notice it's just above, at 4, it's just above 70. So I would say like 72. But you might have gotten a different answer, and that is okay. Probably, hopefully around that. With my different line of best fit, I chose a different line of best fit for my own notes, and I had to go through here. And so at 4, I was a little bit below 70, and so I said 69. So it could be different depending on what you draw your line of best fit to be. Use your best fit line to find an equation of a linear model. Remember, in order to find the equation of a linear model, we need your slope and we need a y-intercept. So we need the m and we need the b. Thankfully, you already have the b right here. I'm going to say 50 for b. The slope is a little bit different. I have this point right here, and I'm going to try and look for points that go through or a place where the line goes through what looks like a crisscross. And here's a nice crisscross, and it happens at 260. So I'm going to use those 2 points to find my slope. My y-intercept, what I have as 0, 50, and then that point on the back page, which was 260. I'm going to use those 2 points to then solve for the slope. If you drew a different line than me, then try and look for that crisscross, try and find the best point that looks like it's exactly there on the line. To find my slope, it's the change in my y values over the change in my x values. And so I get 10 over 2, which is 5, or 5 over 1. So if I were to write my line, it would be y equals 5x plus 50, m and b. You must. Interpret your linear model to estimate how much a student's grade will improve for an additional hour of study. So if we're talking about the relationship and the average type of relationship that's going on here, on average, 1 more hour of studying will result in this thing. We're talking about the slope here. We're talking about the trend or the average rate of change. So we're talking about the slope. So I, in this instance, got a number that divided out very nicely, but on my previous notes, I had numbers that did not divide out nicely, so I kept it as a fraction. So just realize that that 5 is a 5 over 1. If it's not over 1, you need to divide the top by the bottom so that you get it to be over 1. So if you have like a 3 on the bottom here, you need to divide whatever is in the top by 3 and write out a decimal approximation of that number and have it be over 1. Because what it means is that number of hours of study. Oh, no, sorry, Y. I'm so sorry. Y is that's the percentage points for the test, right? For 1 hour of studying, right? Because it's your Y values on top. And so your Y values represent what your test score was versus the X values on the bottom of your slope, which represents the hours of study. So as long as you remember that on the top of your slope represents what's going on with the Y values, and what's on the bottom represents what's going on with your X values. And the reason why we wanted it to be a 1 on the bottom is because it said how much per 1 hour of sleep. So you could do this and then be like, okay, if I study an extra 5 hours, how many more percentage points would I get on this test? That's how you could use that information. In this case, it just asked for 1 additional hour. And so for 1 additional hour, you would predict that you would get an additional 5 points on your test. So for 1 extra hour of studying, a student might score 5% better on the exam. So this is, again, because we're in the applications course, relaying it or bringing it back to the context of the situation. At the very end of these notes, I've got something called correlation versus causation down here at the bottom. And I just want to remind you again that all we can figure out from here is the correlation between these 2 variables. That is it. We do not know that an additional hour of studying will cause 5% extra. We would have to then set up an experiment where we change the number of hours that a student is studying and see if it makes a result. And then from there, our experiment would then be able to draw a conclusion of the causation of how many hours of studying results in how many percentage points for the test. So keep that in mind that all we're really doing here is talking about causation and not, or sorry, correlation. We're only talking about here correlation and not causation. And that is a very common IB term, and it's something that your textbook says you need to know this by the end of this unit, is you need to know what it means, correlation versus causation, and you need to know when is it appropriate to talk about causation and when is it appropriate to talk about correlation. And with these scatter diagrams and with line of best fit and all of that, all you can conclude just from this data is correlation. In order to conclude causation, you need to have an experiment where you test it. Okay, good job today.